solve this puzzle the same way. And I always look at the first difference. So the first difference here is 7, 9, 11. So it's not constant, so I know it's not linear. So I have to look at the second difference, which is the difference between the first differences. I don't know if you guys got that. 2, 2. So if the second difference is constant, then I know it's quadratic. It is quadratic. Which means you have a multiplying pattern. So for your end rule here, you're going to have 2 linear expressions there. And it also means you need to look at factor pairs or a multiplying pattern. So look at factor pairs. Cosmo? Do you have a question?
Yeah. What if the second difference isn't?
If the second difference isn't constant, right now it's not in the scope of the class. Okay. So it's a good question. Okay, so I'm going to look at 8 and think of all the ways I can make 8, but not 1, because 1 times 8 is 8. I'm going to look starting with like 2 times 4, and then remember it's really helpful to draw these columns longer, so you can keep your work organized. I know, that's why I like that tool. So 2 times 4, 15 can be 3 times 5. So 2 to 3 would have to make this 4. So this could work, right? 4 times what? 6. So this would have to be 5, because 5 times 7 work. So if you look at the numbers in the circle, now they have a constant first difference of 1. So I'm going to put a 1 in here, and I'm going to make a rule for just the numbers in the circle. So like 1 times 3 is 3, and if I follow the chute down, I need a 4. I need this. So I have to add 1. Now I want to get numbers. Let's go here. Oh, it's similar. Blue. In these triangles. So I want the 4, the 5, the 6, and the 7. There's still a difference of 1. That's not always going to happen, but right now it happened. Okay? So I still have a 1 in, but when I do 1 times 3 now, instead of wanting the 4, I want the 6. So I have to add 3, and I should check it, right? So 1 times 4 is 4. If I add 3, I should get 7. So my rule is n plus 1 times n plus 3. Okay? And then if I plug in 20, it's going to be 21 times 24. And you guys can figure that out. Okay?
83.
Okay, here's the tricky thing. With the handshake problem and some other problems, whenever you have like, well, let's go back to that handshake problem. This is actually the handshake problem. If you think about it, when you look at the model, see the numbers are the same, 0, 1, 3, 6, 10, 15. So this is the handshake problem. But the big difficulty of this is that when you have, so you're going to want to listen before you write on this one. Let me do something. I'll make more space here. Let me get rid of all of the stuff below. Sorry. I have a copy of that. Okay. When you have 2 prime numbers in a row, this you can't really find a multiplying pattern because you always need a 1 in there. In other words, not just 2 prime numbers in a row, but there's other times it's hard. Like if I look at the first difference anyway, I get a difference of 1, 2, 3, and 4, so I know it's not linear. But the second difference is constant, so it is quadratic. And when it's quadratic, that means we need a rule that has 2 linear patterns. Okay? So if I kept proceeding like I did just a minute ago, and I looked for the only way to get a 1 is a 1 times 1. And I mean, you could say 3 times 1, but then if I followed this pattern, I'd need a 5, and it doesn't work. See the problem?
Yes.
So if you can't get it to work, then try something else. There's a little trick that you can do. So we've already used this information, and I really strongly recommend every time you're done with a set of numbers to cross them out, because you'll lose track of them. Then add another row, and the trick is to get rid of the prime numbers, double everything.
Well,
But if you double everything, what do you have to do to your final answer?
divided by 2.
Divide it by 2. Half it. Cut it in half.
That's my moid.
Okay? So then, now instead of 0 is going to be 0, but 1 becomes 2, and 3 becomes 6, and 6 becomes 12, 10 becomes 20.
30.
Then start over with the multiplying pattern. Are you with me? So now I also just the 0 I'm going to ignore for a minute because it's easier for me to do 1 times 2 and then maybe what do you think? Try 2 times 3. So if we went with Kale's pattern, this would have to be 3, right? And it works. And so this could you could treat 0 as 0 times 1. It could fit into any pattern you want. So I just ignore the 0 and do everything else. Ellery.
So why do you need to double it?
Because there was no way to get a pattern without doubling it because it had 1, 1, 1, 1 and everything, and you just ended up with the exact same numbers that you started with. You can always double, but I don't recommend it because sometimes you can't get your answer simplified as easily. And the numbers get so big that there's more choices. You don't want to double all the time, but if you can't find a pattern, you could double and then see if you can find a pattern. So this next number here would have to be 4 times 5. Okay, so the numbers in the circle go up by 1, so it's a linear pattern. And again, these all start with going up by 1. They don't always go up by 1. And then if I test my value up here, 1 times my m value of 2 is 2, but I need to get the number in the circle. So I do what? Subtract 1. And also, I don't know if you noticed, again, this would be a great time to cross out these numbers, because once I have the factor pairs, I'm not interested in those numbers. And then to get from this 1 to 2 to 3, I'm still going up by 1. So I have a 1 in. But like if I did 1 times 4, I really need to get 4, so what do? Nothing, right? It's just n. So the final answer is n times n minus 1 over 2. And then check your answer. Like check the answer with one of the numbers. Like 5. What's 5 minus 1 times 5 divided by 2? It's 20 divided by 2, right? 20 divided by 2, which is 10. And that's the answer. Do you get that? Is it clicking? So that's the answer. Oh, not that. The rule, sorry, the rule goes I didn't have the rule in here, n times n minus 1 over 2.
Yep.
And then if we plugged in 30, you should get 435. Ellery, did I have it there? I might have. No.
I understand.
I don't know what, I meant to put in formulas, I just made a mistake there, I don't need that shape.
I understand up to where you double it and get the factor pairs, but then how do you get the, rule of the factor pairs?
Okay, I look at the first factor pair, which is circled. The first part of each factor pair is
Oh,
circled.
not the first factor pair, the first part of it.
Yes. The first part. So I'm gonna go to 2 pages so you can continue to look at that, Ellery.
Okay.
But I want to find, let me do something. Let me see. Let's try to do one.
But what about that one there? Because isn't it just plus 1 again, the same thing as up above?
So to get to the second one, the numbers match. The n term here matches the n term here, so there's no adjustment, it's just n. So, I'm not sure, I didn't
You
answer.
double it and you end up with the factor pair.
And
And then how do you use the factor pair to get the rule? And how is that factor pair different from what you would have had up above before you double it?
okay, the factor pairs up above would have just been like 1 times 1 and 1 times 3, and what happens is you don't have anything different than the original numbers.
Okay.
So that doesn't work. So that's why I went to doubling. So then I doubled and got these numbers, so I made a new rule for these numbers. So here are my new factor pairs.
Okay.
And so for the numbers in the red circle, that is this n minus 1 here.
Why is it n minus 1?
Because you have to go all the way back to the top, and the n value was 2. So 1 times 2 is 2, but I need to get the 1. So I have to subtract 1.
So you have 2 and you need to get 1.
Right. Okay, raise your hand if you're kind of clicking on this.
I just have one question.
Yes,
How did you get the negative one?
the negative 1.
That's what
I don't have a, you mean the subtract one?
yes.
Okay, so I'm going to just do a different one up here. I'm going to say my n value is 1, so I'm going to multiply it by 5. But I look down the chute and I really need a 4. So I have to subtract 1 from that n value. I want to get from my n value to this value.
So you have to. Got it. Got it. Got it.
Okay? I'm going to put one more example. I'm going to put 2 videos up tonight. I'm going to stop this, and I'm going to put one more example that's a little bit different, and watch the video before you start the homework. You don't have to watch this one if you don't need to, but watch the other one. I'll make it like a 5-minute video, just so you have one more example where the example I want to put in is where you don't always have a constant difference of 1, but maybe a different constant difference. You guys get that? Now, the paper I gave you, you can do your work on. And when you read the book problems, I apologize for not having them on the board, but I'll put them on the website. You have, can you guys turn to page 112?
Yeah, I can.
You have to make a chart for those problems. Here's what I'm going to do.